Well, good evening. I just went on the air a few seconds early. Here I am. Yes, okay. It's going to be one of those nights. Hang on, it's going to be a bumpy ride. I'm your instructor, Gary, ham radio call sign Whiskey 4 Echo Echo Yankee. And as the monitor says, this is an amateur radio class, a ham class for the technician class license, the beginning license. And we use this book as the basis for the class. It's the American Radio Relay League's license manual, the 5th edition. That's the book that you want. That has the current question pool and answers. And hey, we're on the last chapter tonight. It's safety. Maybe it should be the first chapter, but it is an important chapter nonetheless, whether it's first or last in the book. So that's our plan for tonight, is to go over all of chapter 9. Then we will take a 5-minute break, and then we will come back and take a 35-question practice test based on exactly the questions and answers that you might see on a test when you take your ham radio licensing exam for the first time. So, and you'll grade your own paper. You don't have to share, but it'll tell you maybe where your strengths and weaknesses are, and I'm going to encourage you to continue to take practice tests. So hang in there. We're almost done. Like I said, it's the last chapter. I do want to comment that in the book and in the Dave Kassler videos that I give you links to before class, there's more information in the book and in his videos than you need to pass the license. And so here in our sessions, we kind of focus in on the questions and the answers, and so you may be relieved. There may have been some head scratchers there. You're going, what the heck is he talking about for the Kassler videos, or some passages here in the book? Not to worry. We'll try to clarify tonight, but then you'll also see that the questions themselves are not all that difficult. I want to always make sure that you know the prime directive for amateur radio. And the prime directive is that we have fun. For our Greer Amateur Radio Club, that's the #1 rule, to have fun. And I always say have fun and learn something. But besides having fun, I want to postulate that amateur radio, ham radio, is an adventure. Yeah. Well, Gary, how is sitting behind my radio an adventure? When we hear about adventure, we think of mountain climbing or things like this, but if you look at the definition, you engage in a hazardous and exciting activity, especially the exploration of unknown territory. Well, I think you'll grant me that ham radio so far has been unknown territory if it's the first time. So sitting behind your radio, that's going to be an adventure? Well, yeah, because of the typically hazardous part, and that's why we're here tonight, to talk about safety, because there are some things in ham radio that could, injure you or potentially even kill you. So we need to be cognizant of that. So remember, ham radio is an adventure. So let's start with electrical safety. And again, this is not an electronics class. It's a licensing class, so we're just going to kind of focus in on the test questions, and there's a lot of stuff that we're going to skip as well. So charging lead-acid batteries, a lot of us don't even think about this. I mean, in our cars, typically the internal combustion engine cars have a 12-volt lead-acid battery. Did you know that when you charge that battery, it creates hydrogen gas, and hydrogen gas is flammable? So you need to make sure that if you're going to be charging batteries that you might do for a field day event or for a special activity in amateur radio, that you do so in a very well ventilated area. Another battery safety issue is to keep things away from the terminals of the battery. Batteries store electrical energy chemically inside of them. And if you were to drop a wrench across the positive and the negative terminals of a lead-acid battery, it is capable of discharging a lot of energy right now. So you have a possibility of burns, of fire, or even explosion. So that's something to be concerned about. That's battery safety. Now, AC or DC power, we also want to be concerned of sources of energy that are over 30 volts. Typically, that's the threshold we think of being harmful or potentially lethal. Under 30 volts, not so much, but you want to be careful anyway. If you were to have electrical current go through you, it can heat the tissue in your body, it can disrupt cell function, and it can cause muscle contractions that prevent you from letting go. So that's why if you see somebody who is being electrocuted or whatnot, you don't go over to try to pull them off with your hands, because you could be part of the circuit. Rather, you get something non-conductive and push them off of the circuit. So that's electrical safety. I know when I was a kid, we did things a lot differently. Back in the day, the Boy Scouts used to teach us about electrical safety in a way that would not be condoned today. But it was, Boy Scouts, and we were camping or we were at a meeting or whatnot, and they said, oh, let's have some hot dogs, and we're going to cook them by hooking forks into each end and then taking an AC power cord with the alligator clips clipped to one fork and to the other fork and plug it into the wall. You let the smoke out of the hot dog. It boils inside, it gets hot, and then you unplug it and then you eat the hot dog. Well, I don't want you to be the hot dog, so please stay safe and around energized circuits. And this kind of teaching technique would probably be frowned upon today, but okay, I shared it with you. One thing that I was surprised, I got my start with electronics rather than electrical circuits. And in electronics, when you're wiring, there's a kind of a color standard or a color code, which is completely different from electrical wiring, at least in the United States. So knowing the color codes and what you're working on is important. So here's a standard 120 volt AC outlet in the United States with a wide prong, a narrow prong on the top, and then a circular connection prong down at the bottom. And these outlets are fed by standard with a wire with 3 conductors. The black wire is the hot lead. That's where the source of electrical energy comes from. The white lead we call the neutral. That's the return for the current. And then green is a safety ground. It's an additional ground connection going back to the circuit breaker box. So for AC outlets, black is the hot wire. I said, I started in electronics. Well, in electronics, black is generally considered to be the ground, and red is considered to be the power source or the source of information. So just know that if you're dealing with an electrical circuit, black is hot. In an electronic circuit, probably the red is going to be the hot lead. And don't ask me about defusing bombs. I don't know which lead to cut. Ground fault circuit interrupters are now required by electrical codes locally to be in areas where there might be a life hazard issue if you were to be inadvertently part of an electrical circuit. And we're talking about kitchens, bathrooms, outdoors, garages, things like that. And it's an additional safety system that measures the current flowing from the black wire, the hot wire, which is on the narrow prong on the top, going to the load, and then it measures the current coming back to the white wire, and it wants them to be equal. If they're equal, then it says everything is fine. But if it senses, very rapidly by the way, if it senses that it's sending out more power than it's getting back, or more current than is coming back, that's got to be going someplace, and it says it might be going to a human, and so it breaks the circuit. So if you're in your kitchen, for example, and you have your toaster plugged in and you're hanging on to the grounded kitchen sink and you're touching the toaster, you might become part of the circuit inadvertently, and the ground fault circuit interrupter will protect you. It's a life safety thing. Now I do want to point out GFCIs and ham radio have a kind of a questionable relationship. GFCI devices, especially some early ones from Eaton Corporation, were known to generate radio frequency interference. And since in ham radio we're trying to listen to very weak radio frequency signals, any interference is no good for us. Likewise, some GFCIs, I'm not sure Eaton's or whose, but when you transmit, they're susceptible to RF energy being transmitted and would trip off inadvertently. So just know that the GFCIs are definitely important for life safety, but there can be issues when relating to amateur radio. And here's a link to an ARRL article on that, which you can check out later. So I talked about the ground lead, the green wire. That's a safety ground in electrical circuits. So when we talk about grounding, there are different types for different purposes. And so the green wire is that electrical safety ground, and it's required by local electrical codes. So there's a national electrical code as well that localities may adopt. Grounding may also be used for lightning protection to reduce the likelihood of lightning hitting your house or your structure, and RF signal ground, which is what we are interested a lot in ham radio. So, keep in mind those three things. And it may seem kind of obvious, but 3-wire cords like these here that are plugged into a standard US outlet, that round at the top in this picture here, that round prong, that is the safety ground, the AC safety ground. And it's there for life safety protection, but it doesn't really have any impact on lightning protection or RF ground. There is a faction of amateur radio operators, I'll just make you aware of this, this is extra, not part of the class, that say that you want to disconnect that safety ground to prevent ground loops. We were talking about it just before class started. No, that's not a great idea. Now, there are hams that are going to disagree with me, but keep the safety ground connected. That's what you want to do. Now, for RF ground, for signal ground, what we want to do is to bond all of our radio equipment together, and that's why most ham radio equipment has a grounding lug on the back. And you can use that grounding lug with wire, or let me just turn on my, oops, I lost my, let me turn on my laser pointer here so I can make some notes. So, here we have a transceiver, for example, with a ground connection. Here we have maybe a switch with a ground connection. All of these things go to a common ground bus or common ground point, and then this goes outside to an 8-foot ground stake that is driven in to the earth. And so this is outside. And inside you can use wire, you can use braid. Inside, this is okay, but you cannot use braid like this that you can find at Hamfest, for example, outside, because it'll oxidize, it'll rust, and the connection will become poor. So for outside connections, wire or flat copper strap are recommended. And flat copper strap has a special characteristic we'll talk about in a minute, which makes it excellent for radio frequency grounding, signal grounding. It helps, number one, keep all of the equipment at the same electrical potential, and also can have an impact on noise that you might otherwise receive. Probably not going to start out with a legal limit amplifier, but here is a tube type amplifier. You can see the tube in its chimney here, and the various coils and elements for tuning. And the cover has been removed from this high power linear amplifier. And when you remove that case, there's a switch over here, a spring switch, well, this is what it looks like here, that will open a circuit. It will remove power from the amplifier. It may also additionally ground any high voltage in the amplifier. That's called an interlock. It's a high voltage interlock. It's a standard thing in radio equipment, and you don't want to bypass these interlocks unless you know what you're doing. Sometimes you have to in order to do service on this equipment, but then you're taking extra precautions, because 3,000 volts, which might be on the plate, is certainly enough to give you a bad injury or even kill you. So just know about high voltage interlocks on amplifiers and high power circuits. The other kind of grounding protection, lightning protection, we don't think about it much anymore, but I know back in the day, my grandparents' houses had lightning rods up on the top, and they had cable running down into ground rods. The rule with lightning rods is that you want to have connections as short and direct as possible, and you want to avoid sharp bends in that cable. The reason being, and I won't go into too much detail, but electrical energy from lightning is kind of like a plasma ball, and it has kind of a small amount of mass. And so if it's going along a wire in a straight line and all of a sudden the wire goes off at a 90-degree angle, that plasma ball might just continue going in a straight line and hitting whatever is in its way and damaging it severely. So that's why we say to avoid sharp bends in ground cables used for lightning protection. And you want to follow the local electrical code. And in my own personal experience, I've never had lightning hit a house, but I have had it enter my house through various means. The one that always blew the circuit was my DSL internet connection. I had it in an old house. You know, I had all sorts of lightning arresters. Had the phone company out. It was AT&T. They checked all of their systems and whatnot. But if a lightning system came over that house, it was a vacation house, but it's where I had my ham station, it would always take out the DSL modem. So phone lines, cable TV lines, all of those power lines are all possible ways that lightning can come into your house. Now, obviously, if you're going to be a ham, you're going to put up antennas outside, and so your antennas can be a source of lightning coming in, and so they make what are known as lightning arresters. These are devices that are installed in line. Here's for coaxial cable. So you've got signals coming in from your antenna, going to this grounding block here where this lightning arrestor is. And they come in various different kind of connector types depending on what you're doing. And then this is grounded to a ground rod outside. You want lightning arresters and all this lightning protection to be done outside before it enters your structure. That way the energy can be kept outside and hopefully any damage minimized. And the lightning arresters have gas discharge devices inside that will sense a certain voltage, and when it reaches that voltage threshold, they'll clamp and short out the cable very rapidly to protect your radio equipment. So it's a good practice to use lightning arresters on an outside wall with a ground strap or other copper plate connected to one or more ground rods, very close with very short, straight connections. And if you're going to put up a tower, we need to worry about tower grounding because lightning might not hit the antenna, but it might hit your tower. The rule is to have an 8-foot ground rod for each tower leg. And so in this case, we've got 3 tower legs. We've got 4 ground rods actually. One over here, there's a ground rod there. One back here, there's a ground rod there. One over here, there's a ground rod, and another one over here. And they're all bonded together with mechanical clamps and wire here to keep them all the same potential. Again, we want to avoid sharp corners, and we want to make them as short and direct as possible. Now, I don't get the feeling that so many people in this class are going to be making your own equipment, but we want to talk about this. If you're going to be making your own transmitters, receivers, accessories, things like that, especially if they're going to be AC powered, then you want to make sure that you're incorporating a fuse. Because if something fails inside and there's too much current being drawn, surprisingly, by the device, you want the fuse to blow. So AC powered equipment should always be fused, and the fuse should always be placed in series in the hot lead. Remember, the black lead is the hot lead, so that's the one that you want to have the fuse on. You don't want to have the fuse installed in the neutral. You always want to have it installed in the hot. And if you are working on equipment, always be mindful that capacitors may retain an electrical charge even if the power is removed. A lot of amplifiers, for example, have circuits that are designed to bleed off energy from capacitors inside the amplifiers. But sometimes those circuits can fail. So you always want to make sure that if you're working on an energized device that has large capacitors in it, you might want to remove the power from the device and then even short out the capacitors with a grounding stick to eliminate that stored energy in the capacitors. And okay, I learned electronics back in high school, and in a high school shop, lab, whatever you want to say, we were given access to components like capacitors and power supplies like high voltage power supplies. And being the age that we were, well, and learning what we were learning, we decided we could charge up those capacitors to say 400 volts and throw them to our friend, and we would say, "Here, catch." And they would, and they'd immediately get a shock. So we're trying to avoid that, but okay. Let's answer some questions and see how we're doing. So which of the following is a safety hazard of a 12-volt storage battery?
Bravo.
Bravo. Shorting the terminals can cause burns, fire, or an explosion. Yes, indeed. If you dropped a wrench across the 12-volt battery. Touching the terminals with both hands, no. Okay, it's under 30 volts. It's 12 volts, so you could probably put your fingers on it and not feel a thing. But just be aware that the answer here we're looking for is burns, fire, or an explosion. Think about that wrench that you might drop across the terminals. And what health hazard is presented by electrical current flowing through the body?
Delta.
Yeah, all of those. It may cause injury by heating tissue, it may disrupt electrical functions of cells, and it may cause involuntary muscle contractions. And in the United States, what circuit does the black wire insulation indicate in a 3-wire 120-volt cable? Black?
Bravo.
Black is hot, yes. And what is a good way to guard against electrical shock at your station?
Delta.
Use 3-wire cords, yes. Connect all AC-powered station equipment to a common safety ground, yes. Install mechanical interlocks on high-voltage circuits, yes, all of those. And where should a lightning arrestor be installed in a coaxial feed line?
Delta.
Yes, on a grounded panel near where the feed lines enter the building, but on the outside. And where should a fuse or circuit breaker be installed in a 120-volt AC powered circuit?
Bravo.
Not Bravo.
Charlie.
Not
Alpha.
It is alpha. Good one. Yes, in series with the hot conductor only. And the reason being is the hot conductor is the source of energy coming into the circuit. And you want it to blow there so that energy does not still reach the circuit. If you were to put the fuse on the neutral side, the fuse might blow, but the black wire is still connected to the circuit and still providing energy to that circuit. So if you stuck your hand in there, you'd have a problem. So that's why we always fuse the black or the hot conductor. And what should be done to all external ground rods or earth connections?
Charlie.
Yeah, you bond them together with heavy wire or conductive strap. And what hazard exists in a power supply immediately after turning it off?
Delta.
Yes, especially in high voltage power supplies, there's a charge stored in filter capacitors in the device. You don't want to catch that. And which of the following is good practice when installing ground wires on a tower for lightning protection?
C.
Yes,
Charlie.
ensure that connections are short and direct.
Yes.
And which of the following is true when installing grounding conductors used for lightning protection?
Charlie.
You see that? Yeah, we want to avoid sharp bends. We want to avoid 90-degree angles because the plasma of the energy of a lightning strike could just shoot right off and, hit your car or something nearby. All right, so which of the following establishes grounding requirements for an amateur radio tower or antenna? Who is operative?
Bravo.
Yeah, local electrical codes are always what you must meet. And they may be based on the National Electrical Code. Great, all right. Section 9.2, managing RF in your station. I'm just going to go over here and mute everyone to reduce some background noise. Okay, I'm back. Skin effect. I think we talked about this in an earlier class, but just to reinforce, energy at DC, even a 60 cycle AC, the power out of your wall. We're looking at the conductor here in a end-on view. So here's the diameter of the conductor, and it's copper, let's say. For DC and low frequencies, it uses all of the copper. Electrons flow through all of the copper, the center part, the middle part, the outer part. But for radio frequencies, because of the way that they interact with each other, current actually flows only on the outside of the conductor. No current flows in the center. It's kind of a waste, which is why in very high-powered transmitters, they don't use wire for connections. They use copper pipe because the current will flow on the outside. The inside, it doesn't matter because no current's going to flow in there anyway. So this is called skin effect. The reason that energy, RF, radio frequency energy, travels on the outer surface of a wire, which is why flat copper strap is one of the best grounding conductors that you can use. It's because of its surface area. It has a lot of area, very low inductive reactance, so that radio frequency currents will tend to flow along flat copper strap. And you can buy flat copper strap from ham radio supply stores like DX Engineering, or here's GeorgiaCopper.com, one of the big suppliers. Interestingly, Georgia Copper is no longer in Georgia. The last time I talked to them, they moved to Louisiana, but they kept the name. All right, moving on to a completely different subject, feedback. And I'm not talking about your performance evaluation. We've all been into a basketball gymnasium or something like that at high school or whatever. There's a PA system in there, and somebody turns up the volume a little too loud, and there's an open microphone, and it starts ringing. Well, that's feedback. That's audio feedback. So, here we have a speaker that's outputting, comes back into the microphone, back to a mixer, an amplifier, such and so on. So that's audio feedback. With ham radio, we have to also be concerned about radio frequency feedback. When you're transmitting and the RF is leaving your antenna and going off to the hither and yon where we want it to go for our DX contact with Ghana, let's say, for example, well, some of that RF is probably going to come back toward your station. Back toward your station microphone or toward cables in your station. And when that happens, the RF coming from the antenna getting into your microphone or into the cables, if you're using single sideband, for example, for voice modulation, the result is going to be garbled speech. And you'll have other hams tell you, hey, I think you have RF in your microphone, or there's RF in your audio. That's what they're talking about, is that instead of having a clear, crisp sounding voice, it'll sound very muffled. And you'll hear it sometimes as you start listening on the high frequency bands. Well, how can you eliminate that? Well, move the antenna further away from where your station is, if that's at all possible. And you can use ferrites. Ferrites are a mixture of powdered iron and ceramic material. And you've seen these on cables. Maybe you didn't realize what they were. These little bumps on computer cables for monitors and other things. These are ferrites, and they block radio frequency energy on the outside shield of the cable. And you can also get them for single conductor cables or shielded cables of various sizes. You can also get the toroidal or donut-shaped ferrites that you can wrap wire through. All of that will help to block the RF from coming back in on the microphone input of your transmitter. Ferrites are your friend. Okay, more questions. So which of the following conductors is preferred for bonding at radio frequencies?
Delta.
Flat copper strap, like that we saw from Georgia Copper, because of the surface area. And what is the symptom of RF feedback in a transmitter or transceiver? Charlie, it's the reports of garbled, distorted, or unintelligible voice transmissions. Not sure what they have to do with safety, but okay, it's in this chapter. All right, that was part of managing interference. Now we're going to talk about radio frequency interference, or managing RF, I guess was previously. So there's two kinds of interference. There's interference to others and interference to you. And it's going to happen when people find out, oh, you're a ham radio operator. Oh, that's why my TV's been acting up. Okay, it happens, not so often much anymore. With digital TV is more resistant to interference. But the first question to be answered is your own equipment being interfered with? If they say they're watching such and such a channel with their, and it's wiping things out, and we think it's your transmitter, well, is your TV having the same problem? If it is, they might be right. It might be your equipment that's malfunctioning. If your equipment is working fine, however, then it might be a problem with their receiver or their TV. And the causes of interference to others can be transmitter harmonics. If we transmit on one frequency, let's say in the 10-meter band on 28 megahertz, the second harmonic of 28 megahertz is 28 times 2, or 56 megahertz, which was approaching the VHF broadcast band, for example, for television. So transmitter harmonics could be a problem. Spurious emissions. These are otherwise emissions from your transmitter that are on the frequencies you don't want to be transmitting on, but they're not necessarily harmonics. So spurious emissions or junk coming from your transmitter. That can happen. And third, the more likely situation is that their receiver, their TV or whatever, is suffering from something called fundamental overload. Just nearby strong radio frequency signals are not being effectively blocked by the radio or television receiver. And this is actually, in the modern age where we are right now, is even more of a problem than it used to be, because manufacturers used to build in filtering and things like that to prevent this. But my example is the cheap Chinese radio that you might get from Amazon. They can't reject nearby strong signals on other frequencies. There's no front-end filtering. So that's fundamental overload. There's not much more that you can do about that other than they have to move the radio further away, or they have to get a new radio, something that's better. Don't know how many of you still have a landline telephone, but radio transmission energy, Morse code, and voice and whatnot can be received on telephone equipment. It'll sound garbled, it won't be distinct, and you can buy filters. Again, the ham radio supply stores have these filters. You can filter at the telephone. That's the most effective way to do it. And then the interference is eliminated. Oh, Gary, I'm getting interference. The neighbor is anyway on their television set. Well, there are filters for TVs as well, for either off-the-air broadcasts or cable television. So these radio frequency interference filters that you can put on the receiver can help as well. So you may have to get into this business if your antenna is very close to your neighbor's house, for example, and you're transmitting. Know that the number one cause, though, of poor reception for television especially, bad F connectors. It's almost a given that if you, for example, for cable TV, if you call a technician out, one of the first things they're going to do is they're going to look at your junction box, and they're going to look at the condition of your cables. And in many cases, they're just going to start replacing connectors and cables automatically, because it's the number one source of interference and problems, is not a good connection with the coaxial cable used for reception. So just keep that in mind. Now, we mentioned there's interference to others, so that's what we've been talking about. Then there's interference to you. Maybe something at your neighbor's house is interfering with your radio reception. And the guidance is to work with your neighbor to identify the offending device. Maybe it's the garage door opener or something like that. Politely inform your neighbor about the rules that prohibit the use of devices that cause interference, and check that your station is well engineered and meets the standards of good amateur practice. In the modern world, there's a lot of wireless devices out there, security systems, garage door openers, baby monitors, things like that. And they're all called Part 15 devices. They're non-licensed radio frequency emitters. And all of them can interfere with potentially amateur radio. Amateur radio is a licensed service of the FCC. We have our own rules, Part 97. And so unlicensed devices must give way to amateur radio. So it is incumbent upon your neighbor to fix their device so that they don't interfere with amateur radio. Now, back in the day, I would say maybe you could even lodge a complaint with the FCC. Nowadays, they're probably too busy to deal with anything like that. But that is the way it is, that we are a licensed radio service. We have protection from these unlicensed devices. Okay, what about another licensee, like a broadcaster? Well, maybe a local FM broadcaster, for example, is interfering with your 2-meter reception in your radio. Well, to combat this, you might have to make a little modification to your radio and install something called an FM band stop filter, something like this. It has to be installed in just the receive path, not the transmit path, but it can block strong signals from nearby FM transmitters, for example, in the 88 to 108 megahertz range. when you're designing and building your station, when you can, please use shielded cable, even for power connections, because the shield and the foil prevents signal intrusion into the cable from outside sources, and it also prevents any signals from leaking out of the cable, causing interference to others. So shielded cable is always a good idea. All right, more questions. So which of the following is a reason to use shielded wire?
Charlie.
Yeah, to prevent coupling of unwanted signals to or from the wire. And what would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally?
Would it be alpha?
It would be. This is a case of fundamental overload. The modern receivers without the filtering, the receiver is unable to reject strong signals outside the AM or FM bands. And which of the following can cause radio frequency interference?
Delta.
Fundamental overload, we just talked about it there. Harmonics, yep. Spurious emissions, all of those are possible. This would be causing radio frequency interference to others from your transmitter, for example.
Gary, can you talk a little bit about, harmonics? I know that
Come on back to me, Bruce.
there's multiples of each frequency, but how would that happen?
So it happens in nonlinear devices. When a radio frequency signal comes in at one frequency, for example, and it's processed by output transistors, or there's diodes or other things, what that nonlinearity creates a harmonic that can be output. It could be the second, third, fourth, fifth, sixth, all of those. Amplifiers themselves, if they're not properly adjusted and neutralized, can promote harmonic output. So it's not an uncommon problem.
Okay.
So which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable?
Delta.
Ferrites are your friend. Yeah, it can block that.
Yeah.
And how can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated?
Alpha.
If the device has an external input for reception, if you could put a filter there, if you can block the amateur signal with a filter at the receiver or TV's antenna input, then that might work for you. So which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV?
Alpha.
The first thing you want to do is check your own equipment and make sure that it's not showing up on your equipment. And then check your station, make sure that it seems to be operating properly. There's no defects that you can detect. And which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station?
Would it be Delta?
Yeah, the little board I showed you there is known as a bandpass filter or a band reject filter. In this case, it's rejecting the FM band. And yeah, you could install that inside your transceiver in the receive path, and that would help. So what should you do if something in a neighbor's home is causing harmful interference to your station?
Bravo.
Bravo is correct.
I would say Delta.
Working with your neighbor to identify the device is correct, and making sure your station meets standards of good amateur practice. Yet all of those. So what should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission? What's always the problem?
Delta.
The F connectors. Make sure all TV feed line coaxial connectors, the F connectors, are installed properly. Just replacing them can sometimes work wonders. All right, RF exposure. This was confusing, I guess, from one of the Dave Kassler videos. What I'd like you to consider, now you got to go back to remember the old 100-watt incandescent light bulbs, not the new modern LED ones, but the old 100-watt bulbs, they generated a fair amount of heat. Now, they generated a lot of light and they illuminated a room and they were great, but you learned quickly as a child that you did not put your hand on that light bulb because it was hot. So think about that device. It's emitting energy at light frequencies. Really close to it, if you touch it, you're going to get burned. Really close to it, you're going to feel the heat from the bulb, and the further away you are, the less and less impact it has. And for most folks with a light bulb like that in a fixture or in a table lamp, for example, you didn't even think about it. But that's the same analogy works with your ham radio antenna when you are transmitting. You're transmitting energy, different frequency range than light, and the human body is susceptible to that. And the human body absorbs radio frequency energy at different frequencies, better or worse. And so that's what this graph that you saw in the book on page 9-12, this is the chart of maximum permissible exposure. And it comes from the FCC rules, and it has power density on the vertical scale here and frequency in megahertz on the horizontal scale. And what this is saying is that power density exposure can be higher at lower frequencies, but then as we approach VHF, 50 megahertz and 144 megahertz, this is the body, human body is most sensitive to this region. So that's where we have to keep power exposure down if at all possible. And then as it goes up in frequency, it goes up slightly. And there are two lines on this graph. The top line with a higher exposure level and the bottom line with a less exposure level. This is a controlled area, one where people know that there's radio frequency energy being emitted. And this is an uncontrolled area. You might think about your neighbor's property. They may have no idea that you're a ham radio operator. So exposure for them would be in the uncontrolled area. And it's incumbent now on amateur radio operators of all licensed classes to make sure that their station does not emit energy higher with exposure levels higher than is specified here in this table. And so there are three methods that you can do this by. You can do it based on calculations that are outlined in FCC Office of Engineering Technology Bulletin 65. I'll show you a link to that here in a second. Or you can do it by calculation based on computer modeling. That's what most hams do. Or by measurement of field strength using calibrated equipment. Let me show you the calibrated equipment first. It used to be, I'm going to go over to the green screen here. Used to be back in the day when let me get into the picture. Hi. When I worked for Voice of America, and we had our large overseas transmitting stations, this was something that we had to consider. And we had calibrated field strength equipment. The meters were calibrated and the antennas that went with them were calibrated with them. So we could make direct measurements so that when our high power transmitters were on the air, that we could note any areas where there might be levels of high RF exposure. And they cost thousands and thousands of dollars, and for most hams, they're completely out of reach. Until now. I bought this one on Amazon. And it has frequency range that goes down to the HF spectrum. And you can use this to make direct readings that you can compare. And in my case that I have the, is it right set up? Yes, I think it is. I have the chart. And the only discrepancy is the chart is calibrated in, I think, milliwatts per square centimeter, and this reads in micro watts. But you can do the calibration, you can do the calculation. But so this is possible. Now, these are hundreds of dollars, not thousands of dollars. And it's probably not something that you're going to want to invest in necessarily. However, if you're a member of a local ham club, this might be a good investment for the ham club to get, that they could share with members of the club to actually do measurements at your own station to know, especially, this is especially important if you're going to be using indoor antennas, or you're going to be putting an antenna in your attic, for example. That's going to be near people. And so you want to make sure that the RF output is below the standards, the levels that could cause injury. All right. Now I said that's not the way most hams do it. Most hams use computer models. Here is the OET Bulletin 65. The URL link there is down at the bottom. It's 84 pages long with the math and the calculations you need to go through. Inside the bulletin is this graph. Hey, we've seen this before. It's the same one, just notated just slightly differently with power level on the vertical and frequency on the horizontal. You see here VHF, 50 megahertz. That band, 50 megahertz, is the most problematic. 50 megahertz and 144 megahertz. It used to be about 3 years ago that if you transmitted with power levels below a certain number, you didn't have to do an evaluation. That is not the case anymore. But this is a good guideline anyway to think about when and if you should be doing an evaluation. And note that for 6 meters, 2 meters, this is where the lowest levels are, because that's where the human body is most susceptible. It absorbs energy in VHF more easily than it does at the other frequencies. And RF exposure evaluations are now required by all hams. Now, interestingly, it doesn't have to be a formal written report. It can be a notation in a log or just in your files noting that an evaluation was conducted and by what method. And if you're using an online calculator, I just say print out those results. All right, where do you find these online calculators? Well, the American Radio Relay League has theirs here at this URL. And what you do is you can type in the frequency of operation, the power level, and the type of modulation, voice or Morse code, etc. The Lake Washington Ham Club also has an online evaluator that is very popular. There are others as well, but these are probably the two most popular that I'm aware of. So when do I evaluate? Well, when you're first establishing your station, and then when changes are made to the station. That's when you want to say, is this going to increase exposure? Now, radio frequency energy is different than nuclear energy. Nuclear radiation and RF radiation are different, but some of the same rules apply. So you may have heard this: time, distance, and shielding. These are things that you can do to mitigate radio frequency energy exposure. So time has to do with the amount of time that you're transmitting. If you're a broadcaster, for example, you're transmitting 100% of the time, because that's how you make your money. But with a ham radio operator, we're probably transmitting no more than 50% of the time, and we're receiving 50% of the time. And by taking that into account, you actually can double the exposure level. The other thing is distance. You can move the antennas away from people. The antenna in the attic might, you find that's a bad idea. You really need to get an antenna outside. Or you can limit access to the antenna. Well, how do you do that? Well, it can be as simple as putting up a fence to make sure that people cannot get up close to an antenna that might be transmitting. And I will say that, like if you put your hand on that 100-watt light bulb and you're going to get burned, well, if you put your hand on an antenna that's transmitting, you're transmitting at the time, you will get an RF burn. And radio frequency burns, don't ask me how I know, are the most painful type of burn. They're long lasting and they give you this ugly little scar. So yeah, you don't want that. We need to be cognizant of radiation safety. And maybe as simple as in doing the calculations to know that you need to keep your antenna pointed away from your neighbor's house if it's right up next to your house. Now, I mentioned nuclear energy and radio frequency energy. Nuclear radiation is what they call ionizing radiation. Radio frequency energy is non-ionizing radiation. Frequencies lower than light frequencies are non-ionizing. It does not cause genetic or chromosomal damage, which is something that nuclear radiation can do. But again, the square law rule that you learn maybe in nuclear school it applies with radio frequency energy. You double the distance, the power density goes down by a factor of 4. Double it again, it goes down by another factor of 4. So that helps. And if there's a way you can shield the radio frequency energy from getting to that area, that's another way that you can help. But light is the border between ionizing and non-ionizing radiation, and radio frequency energy is non-ionizing. And remember I talked about duty cycle. So if you're transmitting only 50% of the time, then that means you can double the RF exposure. Now, if you're transmitting FM and radio teletype during that 50% that you're transmitting, those are what we call 100% power duty modes. They transmit full power all the time. Whereas single sideband and CW are modulated modes. So they're transmitting 50% of the 50%. So again, the exposure can go up. So you need to consider your transmit and receive time and then consider also the mode that you're operating. Power density limits are established for full-time transmission. Think about for a broadcaster. They have to follow the same standards. But if the transmit duty cycle is less than 100%, which is amateur radio, then the allowable power density increases. So the example is if the transmit duty cycle is 50%, then the allowable power density can be doubled. I mentioned fences for controlling an area, also signage. Now you don't want the sign on the left. That'll freak out your neighbors. The sign on the right still might freak out your neighbors, but that's the right one. And you can find them on Amazon. An RF radiation hazard sign. If you put this sign up where your antennas are in a discreet way, then you are creating a controlled environment, so that reasonable people who might enter that area seeing the sign would know that, oh, there's a hazard here we might want to avoid. So that you can then change from an uncontrolled to a controlled region just by putting up signs.
That may deter burglars.
That also could, yeah, it's true. And it increases the maximum permissible exposure on that chart. You can use the top line. Fencing, directional antennas, relocation of your antennas, all of those things are things that you can do. All right, let's answer some questions. So what type of radiation are radio signals?
Delta.
Non-ionizing radiation. And which of the following frequencies does maximum permissible exposure have the lowest value?
Bravo.
VHF 50 megahertz. Yep. And how does the allowable power density for RF safety change if duty cycle changes from 100% broadcasters to 50% ham radio operators?
Doubles. Charlie.
It increases by a factor of 2. And what factors affect the RF exposure of people near an amateur station antenna?
Is it Delta?
It is. It's all of those. Frequency and power level of the RF field, so VHF is, the most sensitive. Distance from the antenna to a person and the radiation pattern of the antenna. All of those choices. So why do exposure limits vary with frequency?
Delta.
The human body absorbs more RF energy at some frequencies, VHF, than at others. And which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations?
Delta.
Calculation based on that bulletin that I showed you, calculation based on computer modeling, or by measurement using one of the meters that I showed you, all of those choices. So what hazard is created by touching an antenna during a transmission?
Bravo.
Yeah, you get one of those painful RF burns. You don't want one of those. Which of the following actions can reduce exposure to RF radiation? Reduce.
Delta.
No, reduce exposure.
Oh, relocate.
Yeah.
Yeah, relocate the antenna is the only one there. Relocating the transmitter won't do any good, and increasing the duty cycle is only going to increase the RF radiation.
Yeah.
So yeah. So how can you make sure your station stays in compliance with RF safety regulations?
Problem.
Yes, by reevaluating the station whenever an item in the transmitter or antenna system is changed. And why is duty cycle one of the factors used to determine safe RF radiation exposure levels?
Alpha.
It has to do with the average exposure to radiation.
Mm.
And what is the definition of duty cycle during the averaging time for RF exposure? What are we concerned about? Yeah, we're concerned about the percentage of time that the transmitter is transmitting. Broadcasters, it's 100%. Hams, 50% or less. So how does RF radiation differ from ionizing radiation, radioactivity?
Alpha.
Yeah, RF radiation does not have sufficient energy to cause chemical changes in cells or damage DNA. And who is responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits? Who do you think?
Bravo.
You are the station licensee. All right, last section, mechanical safety. And we mentioned antennas and putting up antennas outside. If you are at all interested in putting up a tower on your property, what I'm going to recommend to you is to volunteer to help someone else who has a tower project. Now, you may not need to climb if you're afraid of heights, but you'll learn a lot just by being on the ground crew. Being on the ground crew, you can see trained people and how they work, where they have the proper personal protective equipment, a safety harness that is up to date and rated for the weight of the climber, a climbing helmet, other tool belts and things like that. The whole point is to be trained, to get some training, to know what you're doing. Don't just wing it. Safety equipment is required at all times. If you're on the ground, you want a hard hat and safety glasses. I remember at commercial tower sites when I was working in broadcasting, you did not want to hear the riggers up on the tower yell, "Headache coming down." That means they dropped something and it's going to hit you. So you don't want that. If you're going to be climbing the tower, you want to make sure you're always tied off to the tower. You have 2 lanyards, and one of them is always connected to the strongest element on the tower at all times. You wear that safety harness, make sure it's up to date and for your weight. The 2-man rule always applies. You don't climb by yourself. You always make sure you have someone else there who, if nothing else, can call 911, but can also support you on the ground. And always avoid electrical lines. So back in an earlier job I had when I was up in Michigan, I used to work for a television station as a maintenance engineer. And one of the things the maintenance engineers got to do was to drive the live truck. We'd go out to various locations and put up a pneumatic mast and point a microwave antenna back toward our tower and beam a live shot back to the station. That was what we did. But in the live truck at our station, there was a plaque that was right above the pneumatic controls for the mast that went up from the live truck. And it said, "Look up, stupid," because you always want to know what's going on up above you before you raise the pneumatic mast. For example, like this. Notice here we have the mast that went up into high voltage power lines. This is all smoke where there was a fire from the energy and whatnot. So when you're erecting a tower or even a mast or putting up wire antennas, know where the electrical lines are. Look up, stupid. And if you're going to put up a tower, and it's going to be a tilt-over tower, for example, you need to know the safe distance from power lines. And that has to do with the tower's extended height, whatever that is, let's say 48 feet, plus 10 feet. So you want to make sure that the base of the tower is at least 58 feet away from power lines. That's called the 10-foot rule. And then this is a tilt-over tower that is nested. It's a crank-up tower. It's shorter, and then you can crank it up to go higher. Crank-up towers must not be climbed when they're just brought up with its aviation cable, metal cable, because that can break or rust or things like that, and it can be a guillotine. So crank-up towers must not be climbed until retracted or until they're blocked. So that they cannot retract. And this is no longer on the test, but I just thought you might be interested. A gin pole is a device that attaches to one of the legs of a tower and is used as a winch with a pulley at the top to lift up tower sections. So riggers can take one tower section and put it on top of another through this device, so you don't have to bring in any outside resources. That's a gin pole. And then when you get your tower up, it may be a guide tower with guy wires. And on guy wires, in order to tension them properly, to make sure that they're all at the same tension and that the tower is perfectly vertical, you tend to use turnbuckles. And they may be really big turnbuckles, like you see here. And they allow you to tighten them by rotating them and adding tension to the wire. When you get it all properly adjusted, then the procedure is to take wire and wrap it through the turnbuckle such that it can't rotate on its own. You have to take the wire out before that would happen. And you do it so that it's really strong, because you do not want the tension to change. To prevent a turnbuckle from loosening, you tie a wire through it, and that prevents it from rotating. And is this a good idea? Mounting your antenna on a power pole that's energized? No. I say it has very high zap potential. You don't want to do that. All right. Questions, last section's questions, by the way. So what is required when climbing an antenna tower?
Delta.
Have sufficient training, use appropriate tie-off to the tower at all times, and wear an approved climbing harness, all of those. And under what circumstances is it safe to climb a tower without a helper or observer?
Never. Delta.
Two-man rule always applies, never. Always have to have a helper. And which of the following is an important safety precaution to observe when putting up an antenna tower?
C. Charlie.
Look up, stupid. Yeah, look for and stay clear of any overhead electrical wires. And what is the purpose of safety wire through the turnbuckle used to tension guy lines?
Bravo.
Yes, it prevents loosening. And what is the minimum safe distance from a power line to allow when installing an antenna?
Delta.
Yeah, the 10-foot rule. Yeah, you were saying it there. Enough so that if the antenna falls, no part of it can come closer than 10 feet to the power lines. And which of the following is an important safety rule to remember when using a crank-up tower?
Charlie.
Yeah, this type of tower must not be climbed unless it is retracted, or that
Never
there's.
want to paint it either.
Yeah, nope. All right, and what is a proper grounding method for a tower? We saw this earlier.
Delta.
Yes, separate 8-foot ground rods for each tower leg, bonded to the tower and to each other. And why should you avoid attaching an antenna to a utility pole?
Charlie.
Yeah, high zap potential. The antenna could contact high voltage power lines. There used to be one of the distractor answers was the power company will charge you more. No. And that, ladies and gentlemen, is the end of chapter 9 and the end of our class as far as the instruction part of it. So what we'd like to do now is take 5 minutes, get up, move around, stretch, but find a piece of paper and a pen or a pencil, and we will together, to conclude tonight, take a 35-question practice test. So come on back in 5. welcome back. So glad to have you back with us. And you never thought you'd make it through the book, did you, when you first got started? But you did. I'm so proud of you. And so now we're going to do a little self-evaluation, see how we're doing, maybe find out where our strengths and weaknesses are by taking a 35-question practice test. I generated and took this test this afternoon, so I'll let you know I passed. But it's practice test number 13. What? This is the first test we've taken together, Gary. Well, we have been teaching this technician class from this book for 4 years, it seems. And so we already have 12 practice tests that we generated earlier. So this is the 13th. And so I'm making available to you in the Dropbox link all of the previous practice tests plus this one, and then next week we'll have 2 more practice tests. So in the end we'll have 15 practice tests. So, but anyway, this is practice test 13 to differentiate it from the other ones. There are 411 questions in the question pool. And the test we take is 35 questions. So if there were no repeats at all, and there will be repeats of questions between the tests, you'd have to take at least 12 practice tests to cover all 411 questions. So that's why I want you to be taking practice tests, and taking 15 practice tests is not too many to get you ready and get you comfortable. And we recommend the ARRL exam review website because it's free. You may have to sign up with your email address, but that doesn't cost anything, and it's used to track your progress. So this is the URL. This is where this test came from, and you can use it yourself. So have a sheet of paper, please, out, and we'll be numbering it from 1 to 35, and you'll be writing down A, B, C, or D, whatever you think the right answer is. Note that on your actual test, the answer order will be changed. So don't memorize A, B, C, or D. That's not going to do you any good. But know what the right answer is. When we complete all 35 questions, we can go back to any question that you might have missed. So if you don't know what it is, just leave that spot blank and carry on. The way we do the test here, there's kind of a time element. So I try not to go too fast or too slow, but if I am doing either of those, just unmute and let me know in the Zoom classroom. And also, if you're done reading the question, in a classroom I can tell when you're done writing, but I can't tell here on Zoom, just briefly raise your hand. That just tells me, okay, I know, and when I see the majority of folks have got their hand up, then I can go on. All right. Wish you the very best of luck. I will not be reading the questions or the answers. I think you can see them all okay. But I will, when we get done, when we go over the answers, I will read the question and just the right answer for our visually impaired folks who watch the class as well. So here we go. Here is question 1. All right, and here is question 2. And now question 3. And here is question 4. And next up is question 5. And now, question 6 is a pictorial. What is component 3? And here is question 7. Next up, question 8. And here we are with question 9. And now question 10. And here we go with question 11. And question 12. And now, question 13. Question 14. And question 15. And question 16. And question 17. Question 18. And question 19. And here is question 20. And now, question 21. And question 22. And question 23. And question 24. And question 25. Next up is question 26. And here's question 27. And question 28. Now, question 29. Question 30. And question 31. Question 32. Question 33. Question 34. And question 35. So are there any questions you'd like me to go back to so you could take another look at it? Just unmute and let me know. I'm not hearing anything. Remember, you don't have to get them all right, but now it's time to assess how did we do. So let's look at question number 1. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? A, the receiver is unable to reject strong signals outside the AM or FM band, 1A. 2, which of the following types of propagation is most commonly associated with occasional strong signals on the 10, 6, and 2 meter bands? That's sporadic E. 2B. What is the term that describes the device's ability to amplify a signal? That's gain, 3B. 4, what is the definition of third-party communications? That's a message from a control operator to another amateur station control operator on behalf of another person, 4D. And 5, which is equal to 1 kilovolt? That's 1,000 volts, 5B. 6, what is component 3? That is a variable inductor, 6B. And 7, why do VHF signal strengths sometimes vary greatly when the antenna is moved only a few feet? Multipath propagation cancels or reinforces signals, 7B. 8, what term describes the use of a subaudible tone transmitted along with normal voice audio to open the squelch of a receiver? That's CTCSS, 8C. And 9, why is coaxial cable the most common feed line for amateur radio? C, it is easy to use and requires few special installation considerations, 9C. 10, what function is performed with a transceiver and a digital mode hotspot? That's communication using digital voice or data systems via the internet, 10D. And 11, what is the disadvantage of air core coaxial cable when compared to foam or solid dielectric types? It requires special techniques to prevent moisture in the cable, 11C, either nitrogen or dry air. And 12, how does the allowable power density for RF safety change if duty cycle changes from 100% to 50%? C, it increases by a factor of 2. And 13, what operating activity involves contacting as many stations as possible during a specified period? Contesting, 13A. And 14, what is the current through a 100 ohm resistor connected across 200 volts? Ohm's law tells us 2 amps, 14D. And 15, which of the following is an important safety precaution to observe when putting up an antenna tower? Look for and stay clear of any overhead electrical wires, 15D. And 16, what is meant by the statement that a satellite is operating in UV mode? The satellite uplink is in the 70 centimeter band, UHF, and the downlink is in the 2 meter band, VHF, UV, 16D. And 17, what electrical parameter is controlled by a potentiometer? Resistance. A potentiometer is a variable resistor, 17B. And 18, how does the FCC define broadcasting for the amateur radio service? Transmissions intended for reception by the general public, 18B. And 19, how is a specific group of stations selected on a digital voice transceiver? That would be DMR, by entering the group's identification code using the DTMF pad on the front, 19C. And 20, on which HF bands does a technician class operator have phone privileges? 10-meter band only, 20C. And 21, which of the following can result in revocation of the station license or suspension of the operator license? Failure to provide and maintain a correct email address with the FCC, 21C. And 22, what proves that the FCC has issued an operator/primary license grant? The license appears in the FCC-ULS database, Universal Licensing System. The database rules, 22C. And 23, which type of voice mode is often used for long-distance weak signal contacts on the VHF and UHF bands? That would be single sideband, SSB, 23B. And 24, how much current is required to deliver 120 watts at a voltage of 12 volts? Using Watt's law, 10 amps, 24B. And 25, which of the following describes a type of antenna loading? That's electrically lengthening by inserting inductors in radiating elements, 25D. And 26, what frequency range is referred to UHF? That's 300 to 3000 megahertz, 26B. And 27, what is an ARQ transmission system? It's an error correction method in which the receiving station detects errors and sends a request for retransmission, 27A. That would be packet radio or PACTOR. And which instrument, 28, which instrument is used to measure electric current? That's an ammeter, 28A. And 29, what is the name for the flow of electrons in an electric circuit? That's current, 29B. And 30, what determines the transmitting frequency privileges of an amateur station? The class of operator license held by the control operator, whoever the designated control operator is, 30B. And which of the following is a reason to use shielded wire? To prevent coupling of unwanted signals to or from the wire, 31A. And 32, in the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable? That's the hot lead, 32A. And 33, what information is contained in the preamble of a formal traffic message? The information needed to track the message is in the preamble, 33B. And 34, what is a transceiver? That's a device that combines a receiver and transmitter, 34D. And 35, how should you respond to a station calling CQ? You transmit the other station's call sign, then followed by your call sign, 35C. So I said you don't have to get them all right to pass. Did you have 30 or 26 right? No more than 9 wrong? If so, you passed. So I hope you enjoyed this, and I hope you enjoyed the presentation tonight. We'll come back next week with 2 more practice tests, just like we took here. If you've taken your test, of course, and you've got your license already, please send me an email and let me know. And especially if you've passed your license and test and you've got your license, we do accept donations. So if you'd like to go to my website, w4eey.com, the class is always free, but there's a PayPal donate button there. We would be greatly appreciative of any funds you can. That helps us for future classes and future videos. So any comments or questions before we conclude tonight? Let me go ahead and remove the spotlight in Zoom as soon as I can find my cursor. There it is. Yeah, go ahead, Patty.
Hey Gary, how long do they allow you to take for the exam? Is there like a cutoff, like an hour or something like that?
There is not. So even though we were kind of under pressure here with some time and whatnot, you won't have that pressure there.
Okay.
You can take as long as you need.
Just wondered. Thank you.
Yeah, of course. Yeah, great question. Anything else? I can't, Angie, are you talking? I can't hear you. Yeah, unmute.
Okay,
There you go.
so if you take it at home, not all the security stuff, but does it look like that? Like we just saw, is it question by question?
I've
How
never
does it
taken a
look?
test online, so I don't know. Does anybody have any knowledge on that?
Well, I took the practice ones on the ARO website. Yeah, it's the same concept. And then they auto score it for you.
Yeah, but
And they tell you what section it is.
if you're going to take your test with like the Alaska group or something like that, I don't know what it looks like. I assume it's somewhat similar.
Okay, they don't have anything local here to go to.
Ah,
So,
yeah,
good.
okay. Alrighty then. Well, you know what I'm going to say. 73, y'all, and we will see you next week.
Thank you.
Bye, thanks.
Bye.